So good evening, everyone. Can you hear me?
Yeah, we yeah.
So let us wait for 2-3 more minutes, then we can start.
Okay.
Okay. So shall we start now? Am I audible?
Yeah.
So shall we start now?
Yes. Yeah.
Okay. So good evening, everyone. Welcome for today's first session, week one session for Advanced Research Trends in Smart Grid Technologies. So I am Gagan
Good
Meena.
evening.
Yeah, good evening. Let me introduce myself first. I am I am Gagan Meena. So I will be TA for the live session for this course, and I am currently doing PhD at IIT Bombay in Power Systems. So let us start with the session then. I hope you are able to see the slides.
Yes.
Okay. So the agenda for the live sessions will be as follows. So we'll first see go through the overview of that week. So for today, we'll go through the overview of week one, and then we'll discuss some sample questions based on the previous year questions. And also simultaneously, based upon the question, we will also discuss some topics related to that questions. And then we'll take your doubts regarding week one. And also this is what I have planned, but you are all always welcome to give suggestions on the flow of the live sessions, how you want to go with the live sessions. That is always welcome. So if you want to suggest some changes, you can always do that. So I hope all of you are going through the assignments. Uh, 3 assignments have been already uploaded, and the deadline for first 2 assignments is 8th February. So after the deadline of the assignments, we can discuss those assignments. For example, in the next week, we can discuss assignments 1 and 2 if you have some doubts regarding those. And for third assignment, we'll wait for the deadline of the third assignment. Then you can see also the live session recordings are also available on the URL. So we'll be sharing this presentation also with you. You can go through the URL, and also it will be uploaded on the portal. You can go through the recordings as well. So let us go through the overview, a very brief overview of week one. So week one was about the introduction, basically introduction to the entire course, and also to the smart grid as a concept. So broadly the week one was divided into these 4 topics. First was introduction to smart grid, then architecture was discussed, then certain standards which are required for the proper functioning of a smart grid that were discussed, and then different elements and technologies which make the smart grid were discussed. So let us see them one by one. So if we see in introduction, we discussed different electrical grid components. Went through the history of power grid, then evolution of Indian national grid, and different regulatory authorities like CEA, CRC, then national load dispatch centers, state load dispatch centers, and then recently, earlier, this transmission planning was a part of power grid, PGCIL, but now separate entity has been formed, CTU, which is Central Transmission Utility, and also there, the below them there are state transmission utilities also for each state. So they together do the interstate and interstate transmission planning. Then we discuss what makes a grid smart. So can anyone of you tell what makes a grid smart? What are the things which we need to add to the a conventional power system which will make it a smart grid?
Two-way communication from the grid and the that end.
Yes, correct. One of the main requirement is two-way communication, and one more thing is required.
Automation using IoT.
Correct. So that is very important. The sensors are very important because we have to, what are we going to communicate? Things which we are going to record or measure, then those things we are going to communicate, and then again that the information from the other side will be there so that we can control certain things through the same sensors. So we need the information communication technology, which include both communication as well as sensors. So if we can incorporate these things, we can make the grid smart. So then we discuss different smart grid components, which you can see. So smart grid components, basically we can categorize them into four main categories. First is smart infrastructure, which can be further categorized into smart energy system, which is already there in our conventional system, generation, transmission, distribution, and then smart information system. So these information, for that also we need this smart metering, smart sensors, PMUs, and information management system. Then second main thing is smart communication. Third is smart management, and fourth is protection. So for the entire reliability, security of system, protection is a very important aspect. And that unless our system is secured, protected, continuous supply of power from generation to load is not possible. And which is the aim of power system, to economically deliver the power from generation to load. Then we discuss the architecture of the smart grid. This, so there are main seven components which together make this smart grid, which you can see, and this model which we see here is based upon domain. It is a model based of cyber security framework. That is why we see these clouds. So each of these components are represented by these clouds because in cyber security these are called domains. They are called domains and they have to interact with each other for the proper functioning of the smart grid. Therefore, we represent them through this cloud. This is also written here. It's a domain. So all these are different domains which have their own functions and they communicate with each other. Power flow is only between this transmission, from generation to transmission to distribution, and then finally to the customers. The rest is the flow of energy, flow of information. Then we discuss the standards for smart grid. What is the need for standards? One of the need is interoperability, and then we discuss the benefits of interoperability. And then we also discuss different standard development organizations. So can you name some of the standard development organizations? Any one of you? Any one standard development organization that you remember from the lecture? I hope I'm audible. Hello, am I
Uh,
audible? Yeah,
IEEE standards.
correct, correct. IEEE is one of the standard development organizations, and then we have IEC, International Electrotechnical Commission. Then, so these were the different standards which were discussed. First was standard for distributed energy resources, then standard for VASA, wide area situation awareness, then substation automation and protection, time synchronization and cyber security. So we discussed all these standards for these different segments in the in week one. Then we finally discussed the elements of technologies of smart grid system. We discussed the advanced metering infrastructure, then what are the networking options available for advanced metering infrastructure, then what are smart grids and what do they measure, and finally we also discussed the distributed automation system. So distribution automation was also discussed. So let us move to some questions, some sample questions for the material which was covered for week one. But if while discussing the questions, I will also give some additional facts, some update to the data which have been shown in the slides. But because the slides were posted uh, 2-3 years back, so data is not updated is in some slides. So I have also updated those data. So first, let us talk about the HVDC system, HVDC projects in India. So, do you know when was the first HVDC line project, any line, HVDC line built in India? Which was that line and when was it built?
No, sir. No idea.
So, can you tell why do we use HVDC? And what was the need to go to HVDC? Because we were having HVAC transmission system also.
So losses will be less compared to AC.
Yeah, that is true. But that main reason for going to HVDC was recently developed between Northeast and Agra. Yeah, yes, Akansha, that is correct. One recently one line has been HVDC line 800 kV HVDC line has been commissioned between Agra and Alipurdar to which is up to Bishwanath, which we can see here. This line number 11. So main advantage of HVDC over HVAC is in terms of transmitting bulk power over a long distance. For a shorter distance, HVDC is not economical. It requires less space because the right of way, right of way is the land which we require to build that transmission line. For HVAC, we need to clear larger area of land. But HVDC requires less right of way. But this HVDC is only done when the distance is very large, as we can see in this diagram, in this graph between Agra to see northeast. It's a huge distance. So if we use HVDC over such a huge distance, then we have much advantage. It's economical also, and we get higher efficiencies. There are other advantages also because it is DC, corona losses are not there.
Yes, sir.
So that is the main advantage. So we generally use it for a very long distance. We can see all these lines are very huge, very long distance lines. So first HVDC line was built in 1989. So it was this Barsur Celeru HVDC line. So if we see HVDC projects, generally HVDC, whatever which we have in India, they fall into these two categories: back to back and point to point. In point to point also there are two, bipolar and monopolar. At we all the lines are bipolar mostly. Only two lines are monopolar because first one is this Barsur Celeru because it was built in way back. That time the HVDC concept was new, so we went for monopolar only. It was simple, it is more economical. So because of those reasons, we went for monopolar. But as the technology matured and advanced, we went for the bipolar one, which provide more reliability. So these are the different bipolar lines which are available. And among bipolar in India, up to around 2000, before 2017 or 15, all the bipolar lines were of 500 kV rating. Voltage rating was 500 kV. But after 2017, we can see there are these three new lines were there. They were commissioned. One is this Kurukshetra Champa Kurukshetra, then this Rajgarh Pugalur, and then Agra Vishwanath. These three are 800 kV lines. And then we have these back to back. So do you know what is back to back? What is difference between point to point and back to back HVDC lines?
No idea, sir.
Okay, so let me tell you. So we can see all these are in the map. We can see for point to point lines, we can see that there are two dots, separate dots, and between them there is a connection by a transmission line. But for back to back, you will see only four stars. That means there is connection, but that is very small. Because these back to back converters in this, the inverter and converter both are placed in the same substation, and they are connected with a very small, sufficient to connect them. Only that much sufficiently small line is used to connect these inverter and converter. But in point to point, we can see converter is at one place, inverter is on the other place, on the other side. So that is the main difference. And also the one more important point here is up to this from 1 to line number 13, all these lines were based on thyristor. So they were all current controlled. Based on this thyristor, silicon thyristor, SCR technology. But recently, we have also come up with India's first VSC, voltage source control based HVDC system, which is this 14th between Pugalur and Thrissur. It is very recent and even it was commissioned last year itself. So this is also monopolar, and this is 320 kV rating line. So as this technology also advances in future, we can see the bipolar lines as well based on this voltage source converter based technology. So this is one update. So let us move to our first question. Do monopolar have advantage over bipolar? The advantage of monopolar is over bipolar is that monopolar is it's simple. Its design is simple first of all, and when another is it's economical. Because in bipolar, what in monopolar there is only one conductor. There is only one conductor between the inverter and converter, and it is preferably negative conductor, and the return path is through the ground. But in bipolar, there will be two conductors, so the power will go through one conductor and it will return from the other conductor, not from the ground. So advantage of bipolar is that if one of the conductor goes away, there is a fault in one of the conductors, then we are still able to serve half of the load through the other conductor. But this flexibility is not there in monopolar. So if there is a fault on the conductor in the monopolar case, we will not be able to continue giving supply to the load. But since it is simple and it is economical, we went for monopolar, and we can see that this monopolar was built only in 1989. After that, we didn't go for monopolar. Yes, bipolar is better, much better. Over between these two, bipolar is best. So we can see all these lines are bipolar. This is the first line, so it was monopolar because at that time it was initial stages of HVDC. Similarly, because it is our first project of VSC, monopolar is economical and simple, and to begin with technology, we start with the monopolar. And in future, we can see bipolar also. Okay, any other questions for HVDC? No, then let us move to our first question. So this is the first question. Which of the following is one of the key features of a smart grid? So who would like to answer this question? It's a very simple question.
Centralized generation.
Are you sure, Adish? It is asked which is one of the key feature of smart grid, not conventional power system. So think once more and then answer.
It's pervasive control.
Correct, correct. So why do you say so?
Like centralized generation is also a feature, but the main, if we consider the smart grid, we can see the pervasive control is also a main thing.
I want to ask, what is how pervasive control is beneficial? Was it not there in the conventional power system? Akansha has answered that because we have full control over power flow and better communication and bidirectional power flow too. So pervasive control, uh, that is correct, because if you see the difference, if you see the first option, the first is limited sensors. So it is a property of conventional systems where we have limited sensors, especially most of the sensors you will find in the transmission system. In distribution system, we have very limited sensors. But in smart grid, we are talking about two-way communication and sensors all over, generation, transmission, distribution, everywhere, so that we can get more and more information and also communicate to the other end and take required control actions. So pervasive control is one of the key feature of smart grid, so that we can have control over everything. Centralized control, it can be decentralized also, but we should have some control so that we can have a lot of flexibility over different things and we can take actions very quickly. Centralized generation is actually a key feature of the conventional power system where we had this vertical integrated system. So where we had this generation, then transmission, and then distribution. So power was flowing only in one direction. But now we have decentralized generation. Even our house, our homes, they are also producing power. They are also feeding into the grid. We have grid tied solar rooftop PVs. Even we can have electric vehicles. They can also feed to the grid in vehicle to grid mode. We will also see in the future, in the upcoming weeks, that energy storage can also do the same thing. It can be charged and it can be discharged to feed into the grid. So now the generation is no more centralized. Centralized generation is also there, but generation is distributed also. There are so many small generation also, especially at the distribution level. And we can have even big generations like solar and wind farms at distribution level also. So that is why the generation is no more centralized. There are centralized as well as decentralized generators. Yes, Adish.
Yes, sir.
And yes, you want to ask something?
Sir, and also now there is an increasing trend and on e-mobility, so electric vehicles are developing so fast. And how would you put on with the smart grid from this side the supply and the demand for EV for the storage or battery storage for charging those with the smart grid?
Means, if I get you correct, then means you want to understand how the e-mobility and this battery will be incorporated into smart grid. Am I
Yes,
correct?
sir. Yeah, yes, sir.
Yeah, so it's a good question. So in smart grid, right now what we are having, the load which we have generally, it used to be based upon historical data. We were able to forecast the load to certain accuracy with some tolerance. We were able to forecast and we were able to generate according to that. But now these electric vehicle will come into picture and they are very uncertain. Their charging pattern will differ. Although it is right now we are gradually going into that, so we are not having that much problem. If at a time so many electric vehicles they are charging, and that can put stress to on the existing grid. So we have to plan accordingly how good we are able to accommodate this increasing variable demand in the form of this electric vehicles. And when we talk about electric vehicles, we usually think two wheelers and especially four wheelers. But if we take the wider spectrum, then electric vehicles they include these. Now people are also thinking about these hydrogen based trucks and buses or lithium ion based buses. So they are also a part of e-mobility. Then also these, you would have heard of this rapid rail transit system between this in NCR. Several metro projects are also coming up. So all these are also electric load. They are a part of e-mobility. So all these upcoming in the upcoming years, this load is going to be increased, and these four-wheeler, two-wheelers, different TVs will offer unpredictable demand to the grid. So for them, we have to develop new we can say algorithms, new ways so that we can better predict their demand beforehand. And this electric vehicle in this sense is we can say will create challenge to the grid, but it has several advantages also. For example, we can, if there is no power supply in our home and if our electric vehicle is charged, so in vehicle to grid mode, or vehicle, we call it vehicle to home. So in that mode we can use some energy from electric vehicle and do some our minimal jobs at home. We can do that. And also there is concept of these aggregators, virtual power plants or aggregators that we have seen in this domain of distribution system. So these P2G might reduce the battery capacity. Yes, it will certainly reduce the state of charge of the battery. And I think, Akansha, you want to say in terms of degradation of battery, if I'm not, yeah, correct. So you're talking about the degradation of battery. Yeah, that is a challenge. That is true. Many papers they talk about this thing that frequent charging and discharging of any battery will result in certain degradation of battery. But there are the technological advancement in, but they hope, the scientists they hope that in future new technology will be there. Okay, you are working in virtual power plants, so that is true, but there are certain optimization techniques and certain algorithms are being designed so that we can minimize this uh, degradation of battery. And also there has to be changes in terms of the battery chemistry itself. New technologies, new battery technologies has to come up, and there is a lot of research going in that direction. How can we reduce the degradation? One there is one project, I think it is based in UK. So they use a hybrid lithium-ion battery as well as a redox flow battery. So for frequent charging discharging operation, they use the flow batteries because flow batteries have a good life. So for that purpose, flow battery is being used, and for normal cycles, the lithium ion is being used. But although that project is for a large level, not for at a electric vehicle level, it is a the battery is around 50 megawatt. It is for an entire campus, like we can say. But still, I think some new technology need to come up for that. So can you light in current scenario what work till now in virtual power plant? Oh, that is a very specific question, Akansha. I think, but I have not. I will have to see for that because I am also not aware about the current updates in the virtual power plant uh, side. So I will have to see that and then tell you. So any other question for any doubt for this question? The fourth one was this electromechanical operation, which was especially meant for the circuit breakers. We used to have these electromechanical circuit breakers previously, but now they have been replaced. Some of them may even use it, but mostly we use these numerical based or digital relays. I have a doubt in week two. I think Akansha, for week two we will discuss in the next week. This is let us first cover the portion for week one. Then if we have time, then we will go to that. Otherwise, we'll discuss that in the next week. So we have divided, as per the plan, we have divided this each session based on each week so that we can give proper weightage to each week. So we will try to first of all cover this week material. So the answer is pervasive control. Let us move to the next question. Yeah, same thing we have also discussed. What is pervasive control? We have already discussed that. Because in smart grid we have extensive flow of data because of two-way communication. So we can control most of our assets, and that can help us in faster failure detection as well as quick restoration and self-healing without operator's intervention. So this is one of the biggest advantage. So we all want that our system becomes a self-healing. Small disturbances, even up to certain extent, some large disturbances also can be handled automatically based upon the intelligent information system and the control system. Then it will be a good. That is the our we can say aim of our smart grid to develop a self-healing power system. That will require time, so we are working in that direction. So next question is this. What's the total installed capacity of renewable energy in Indian power scenario as per MNRE 2022 in gigawatts? So who would like to answer this? So any idea about this? What is the current scenario in our in our power system? How much installed renewable capacity are we having?
About 250, if I'm not
Okay,
wrong.
okay. Any other guesses? So Harish, you are slightly away from that actual figure. We are not still, we are around 100 gigawatt away from that 250 target. Yes, Akansha is correct. So it is 113 gigawatt. So it is approximate, but actual figure we will go through. Let us see the actual figures also. So this is our Indian. There are some key figures and update to the information. New update for you. So these are the key figures of India by 2020 up to the last year, December 2022, and some figures are also for 2023. So if we see the energy mix, we earlier we were having only coal, oil, gas, diesel, and hydro, and now we are very vigorously moving towards renewables, especially solar and wind. And among the two, solar is on a higher end. If we see the electricity consumption in terawatt hour for 2019-20, it is very huge. It's 1248 terawatt hour. And our electricity generation capacity, this is the installed capacity. So till December 2022, it was 410 gigawatts. This is the total installed capacity. The peak electricity demand met in gigawatt. This is a recent figure in January 2023. First time we went, I can say, above 200 gigawatt.
Sorry, screen is not visible.
So screen is not visible. Uh, is it same for
Presentation.
others also?
No, sir, it's visible.
I think you should try to log in again.
Okay, sir. Okay. Okay. I thought it is for same everybody. Sorry, I will check.
No problem.
Okay.
You can just re-log in.
Okay, sir.
We were on the peak electricity demand mat. So it is around 210 gigawatt, and then we moved to this deficit. So up to December 2022, there we are still having a deficit in electricity demand. Especially the peak demand deficit is around 4%, and energy deficit is less compared to the peak demand. So we have to work on, especially on this peak demand deficit. And recently, if we see the trend of this peak electricity demand over last 10 years, we can see that over past 4 5 years, there has been before 4 5 years it was around zero point 0.5, even deficit was very less. It went up to zero point 0.5, I think, but then it has increased over last 4 5 years. You can say it is the main contribution to this deficit increase in this deficit is renewables uncertainty also. So moving on to 100% renewable grid is really a very big challenge that we have to develop some ways to reach that goal, to meet that goal. For India, as per the government targets, the target is that by 2030 we have to achieve around 500 gigawatt of energy should be from non-fossil fuel generation, and out of which around 300 gigawatt is planned to be from solar. And by 2070, correct, Akansha is correct. So by 2070 we have to go to net zero energy. So can you tell any one of you, can you tell what actually the net zero target is? What do you mean by net zero? Is this mean 100% solar wind or 100% renewables? What does this mean? And net zero target. Carbon emission is zero. Uh, and you are partially correct, Akansha. So its carbon emission is not zero. You have missed one small term in this sentence, in this line. That is a very important concept, and that is the difference between net zero and 100% renewable. Anyone else would like to try? What do you mean by net zero? Okay, let me tell you. So net zero, the word net is a very important in this net zero criteria. So net means, when we talk about net, suppose there are three numbers, 1 minus 1 and 1. So their net sum, if we take, it will be 1. Or let us take 1 minus 1, 1 minus 1. So net sum is 0. Actual sum is 0. But if we take the absolute value, it will be 4. So net zero doesn't mean that there will not be any carbon emission. There will be carbon emission, but that carbon emission will be offsetted by some technology so that overall, as a net, there will be no carbon emission. So it is that thermals will be there in net zero, thermals will be there, or some other gas-based generation may be there. They will be releasing some carbon, greenhouse gases and carbon emissions, but that emission somehow will be offsetted. Either it will be recovered using technologies like carbon capture, or it can be offsetted by afforestation. So is it clear now? So so how can we define net zero EG? So what is EG here? Oh, energy grid. Okay, sorry. Yeah, that is the same. So net zero energy grid will be, that means the net zero here implies to the carbon emission. So net zero energy grid will be when our net carbon emissions from the grid side is 0. So whatever we are generating from, if some thermals are there, so net zero is there, that means we are assuming that some gas based or some fossil fuel based generation will be there, maybe for balancing purpose. So they will be there, but we will offset the emissions by those fossil fuel based generation by some technology such as carbon capture. So that net is Gauri, screen is not visible. I think you should try to re-log in. I think screen, is the screen visible for others?
Yes.
Yes. So yes, Gauri, I think you should try to re-log in. So Kansha, is it clear now? Net zero concept. Okay. So let us move to next figures, next concept, so facts. So this is the installed capacity, all India installed capacity as of December 2022. And also let me tell you one thing that, so do you know where can you get these figures? Suppose you want to know what is the all India installed capacity after 1 year. You want to know how, from where are you going to get these figures, this data? Minari will mostly provide the data for renewable side, but if you want to know the entire all India installed capacity, the Central Electricity Authority, so the Central Electricity Authority, they publish their report every year, every month also. They have monthly and daily reports. So whenever they update the report, they post on their website. I have mentioned all the links in the references. Also, you can see on the bottom of the slide. So after that, the Power Ministry also updates the same data on their website. So from there, you can get this entire data, this entire all these things which I am mentioning, which we will see in the subsequent 2-3 slides. Also, you can get all this data from the Ministry of Power website. So in future, if you want to know, you can get the data directly from those. You will get the recent up to I think 1 or 2 months before. So till now they have updated only up to December 2022. So there is a lag of around 1 month. They take time to get the data from all the substations, and then from all the SRL regional load dispatch center, they compile it and then they publish the report. So they take some time for that. So you can get the data from there. So let us move to the all India install capacity. We can see still in the installed capacity we have around 50% contribution is still from thermals. So which is around 235. There is a small typing error here in the slides which will be uploaded. I will correct this mistake. So this should be gigawatt, not megawatt. Our install capacity is in gigawatt. So that's sorry for this mistake. So 235 is thermal, then hydro is 46 megawatt. And if you when you will visit those sites, you will see that hydro and RES have been mentioned separately, but together they are called renewable. But specifically for solar, wind, and other kind of renewable energy resources apart from hydro, they have clubbed them together under RES. So this RES will be solar, wind, biomass, waste to energy, and small hydro plants. So let us move to the next one. So this is the RES capacity. Here again also this mistake is there. This should be gigawatt. So solar, among all the renewable resources, solar is maximum, which is 63 gigawatt, and wind is 41 gigawatt, and biomass is around 10 gigawatt, and small hydro is 50 gigawatt. And this is the electricity consumption pattern. If we see the highest contribution to our electricity demand is from industrial sector. It is around 42%. And the next is domestic. Even right now the traction we see it's only 1.53%, but this is going to increase substantially. So what is the difference between this industrial and commercial? What are the industrial loads and commercial loads? Can anyone of you tell the difference between the two? You will come across these terms whenever you see the reports. Yes.
Sir, what is the question, sir? Once again, domestic and commercial load you are asking.
No, I'm asking industrial and commercial.
Okay, industrial and commercial. तो
Any
कमर्शियल में
guess?
तो सर ये
Yes.
शॉपिंग, जैसे फॉर एग्जांपल आई एम जस्ट टेलिंग, ये शॉपिंग मॉल वगैरह जो है वो कमर्शियल लोड हो जाएगा.
Correct, correct. You are correct.
एंड
Absolutely correct.
इंडस्ट्रियल तो सर जो है सर्विस, अपना जो मैन्युफैक्चरिंग और
Mhm.
इंडस्ट्रीज है. हाँ हाँ सर, इन जनरल.
Correct. Even Venkat has also mentioned the same thing. That is correct. The shopping complexes and big buildings, they come under commercial loads, and the industrial are our industry sector because that is a huge load. One industry can be a very big, some in hundreds of megawatt also. So these big industries like the Reliance Industries or any other big industry, they will be having a very huge load. So I think this has been covered. We have answered this question. This is 120 or 113 gigawatts. This is repeat. Sorry for the repetition. This is also we have discussed that in COP26 Conference of Parties. This is every year organized by UNFCCC, United Nations Framework on Climate Change. So India has promised five five targets, which they call Panchamrit, and one of them is to reach 500 gigawatt of non-fossil fuel energy capacity by 2030, and the net zero emission by 2070, which we have discussed now, which we have already discussed. So the next question is, what about the other four? Other three I have not mentioned, but I have shared the link in the slide. You can go through that. They are not directly related to power systems, so I have not mentioned them. So, but I have shared the link. You can read the rest three of those. So, so what is the full form of IEC? Who can answer this question? So IEC is
B option, sir. International Electrotechnical Commission.
correct. So what is IEC?
Here, sir, is standard body. They create a standard for this electrical and electronics.
Correct, correct. So we have discussed them in our week one material that
इंडस्ट्री स्टैंडर्ड्स दे क्रिएट सर. इसमें
yes.
क्या रहता है सर, एक जनरलाइज हो जाता है. नहीं तो प्राइवेट में अगर कुछ सम इन्वेंशन इज डन वो पेटेंट कर लेते हैं तो वो उनका प्रोप्राइटरी हो जाता है, तो वो स्टैंडर्ड के थ्रू ओपन अप होता है मार्केट के लिए. जनरलाइज हो जाता है कि सब लोग सेम उस पे रहे प्लेटफॉर्म पे, अगर डिफरेंट मैन्युफैक्चरर हैं तो.
That is correct. And different manufacturer to have interoperability that we have discussed earlier also, that in smart one of the features of that need for standards is interoperability. So if we have, suppose all over the grid we have relays which are manufactured by different entities, different private industrial companies. Then if they follow different things, then it will be a mess. It will be very difficult to control all these relays. Not only relays, right nowadays we have these inverters, solar based inverters. We have grids, such huge solar and wind farms, and they are connected to the grid through these inverters. So the control strategies which are embedded into these inverters, they need to be standardized. Otherwise, there are several problems. So we call it a grid code. Also from these utility also, there are grid codes. Those are standards which these companies have to follow, and these grid codes are based on these in the standards which these standard development organizations provide. They develop these standards, and then different utilities in different countries, they formulate their standards based upon these standard development organization standards. So one of them is this International Electrotechnical Commission. Other is IEEE also. So do you know the full form of IEEE? I think as an electrical engineer we should know. So can you tell the full form of IEEE? I think we have covered this in week one also.
Institute of Electrical and Electronics Engineers.
Correct. Thank you, Gary. So that is correct. IEEE is a very old organization, one of the standard development organization, and there are several standards which we follow. And there are one recent standard has been incorporated even by by Indian Grid also. In the Indian Grid code, we'll find those IEEE, those standard based upon IEEE 2800. So we will discuss that in next week also, after your assignment is done. So now let us move to the next question. So answer for this is International Electrotechnical Commission. So the next question is, wired communication system consists of which of these following? This is, I think, this is also a very simple question. Correct, correct. Akansha and Sunil have answered correctly. So answer is C, fiber optic communication. So cellular communication we can easily understand, it is which we use in our mobiles, earlier in small phones also. That is, that involves satellite communication also. And so satellite communication is a part of cellular communication also, and we can directly even communicate with satellite also. Then optical communication. Can anyone give example of some optical communication? Why is is it not a why is it not a wired communication? Means how do we go about this optical communication? Have you come across some kind of any kind of optical communication? Anyone? Any guess you would like to make based upon the terms which are used in optical communication? So optical, we see in all the four options, communication is the common link. But based upon optical, can you make some guesses how this communication would be done? So cellular, we can see it is, we use cell phones for communicating. Satellite, so communication is through satellite, via satellite. Fiber optic, we use fiber optic cables for communicating, for sending information. And so optical means, what are we using as a medium for information exchange? So what is that medium in case of optical communication? Just any guess also would work. Okay, it also uses fiber, I guess. Uh, okay, fiber optics, because it is based upon principle of optics. So you are saying it may be because of that, but it's a good guess. But actually, optical communication, it uses some kind of light, but not through cable, a fiber optic cable, but directly into the through air. So
Sir,
there is
might be the best example of X-ray machine, we guess.
X-ray machine, but X-ray is not it's not a light, right?
उसमें communication कुछ नहीं हो रहा ना. No communication is done, I think, in X-ray.
I think he's saying that because in X-ray we can see some on the film, we can deduce something from the image,
Yes,
sort of, we can say. But
I
actually
thought.
in optical communication, yeah, that is correct. Means in that sense you can say, but here what we do in optical communication, we send light through air. We can directly send light. And have you heard of Morse code? In some movies, like especially in these movies based upon these intelligence agencies, you will find
हाँ.
they will frequently use
Morse
this term Morse code for communicating some secret information. They don't want to speak, but they want to communicate. Still, they want to communicate. So they will tap their fingers or their blink their
They
eyes.
want to alert, हाँ alert करने के लिए बिल्कुल सही.
Correct. So they use something, some either they will blink their eyes in certain fashion. So each blinking has some special, some character for that. So frequency of blink will, suppose you are blinking it one time, it is some A character. You are blinking your eye 3 times, it is some C character, something like that. So they have that encoding is done. So then they both of them know. Even mirror reflection can also use as a code. Yes, that can be done. That is true. So what they will do, they will flash the light in certain pattern. So if you are flashing the light one time, you will just dark. You will suppose there is a lamp or laser, then you are switching it. You are on off on off. You are blinking it with certain frequency, and that frequency will be decoded on the other end. So that is a kind of optical communication.
Can I tell you something?
Yes, yes, sure.
Actually, I'm an industry-oriented person,
Yes, yes.
and we used to use the same optical communication for a moving object to get the data from a moving object, some rotating.
Mm-hmm.
Even in packing units, there will be a packer will be rotated. So how much packing has been done and what is the spout capacity, everything, it will transfer the data to a constant object through this light optical communication, and it exactly light. It works on the principle of light.
Correct. That is. Thank you for this good example.
Thank you.
That is true. So in that way we can. So for that we need to have some encoding, decoding. We should have some. Already we should have developed some kind of way so that we can deduce what that message is.
Can code something.
Correct. There can be different codes can be used. Morse code is one example. One, as Sunil has mentioned, CAM code. That is also one example. There are different codes which can be used for that. So let us move to the next question. So answer for this is fiber optic communication, as you have told. Then okay, this is a good, interesting question, and we will also spend some time discussing this concept. It is a very important concept of power system. I think we should know this. So let us go with this question. So what is the objective of the ancillary operation in the market domain is? A, B, C, D. You have first option is sell power to end users. So Akansha is with option A, that is sell powers to end users. And so what are your guesses for other, means guesses or intuition? I think intuition would be a correct word for this. Based upon what you have studied in the week 1, you all would have watched the lecture. I think this is the third lecture 3, where we were discussing about architecture of smart grid. We have discussed different domains. One of them was market domain, and in that we were discussing in this VLSI session. Sorry, I didn't get what is VLSI. Shinu, can you elaborate what is this VLSI? I didn't get that. So we were discussing about the market domain in that lecture. I think you would have come across these things.
Provide frequency support.
Correct. Govind is correct. So, do you know what is ancillary services? What are ancillary services? Have you come across this word before?
Yeah, actually, these are for short-term uses. Basically, certain plants for who are termed as ancillary service providers. So there are certain designated plants which will participate in such type of market, wherein they are called to ramp up or ramp down their generation as per the frequency. And in turn, they are provided some compensation as well, financial compensation for that.
Correct. So we will discuss about ancillary service more in detail now. So frequency regulation, as we can see in one second option, providing frequency support, is this is one of the ancillary services. There are other ancillary services as well. And so as per, so first one answer was, someone gave one answer as sell power to end users. Other these options like make a particular market function smoothly. All these are operation, these are function of market domain. But for ancillary operation, the option B is the correct. So let us see what are ancillary services. So I think it is visible. So these are the necessary services which support the grid operation to maintain power quality, reliability and security of the grid. So there are three types of ancillary services. One is frequency control ancillary services, which was in the option supporting the grid frequency. Second is network control ancillary services, and then system restart ancillary services. So in network control ancillary services also there are two types. One is voltage ancillary services, which can regulating the, it is for regulating the voltage and for also for providing the reactive power support. Because these two are linked in transmission system. Then second one is power flow control ancillary services or load following. System restart ancillary services include like black start. So have you heard of black start? I think when there was a blackout, a huge blackout in 2012. Yes, so that time you would have come across this word black start. Even in 2020, there was a blackout in Mumbai. So whenever these blackouts happen, we need these services. So black start are those services which, for again, you want to start your generation. So for starting those generation, because if there are no generation, how are you going to start those generation? Because those generation also require auxiliary. They have many auxiliaries with them. They need some power to start generation. If a thermal generator is there, it need, before generation it has to be brought to a certain minimum temperature and pressure level. Then only it can generate. So how are we going to reach that when there is no generation? For that we need these services. So some generator, some diesel-based generator, or some other generator, or some from some other region or country, we can get some generation to start our generation. And such type of services are included in Black Start. And in the week coming, I think week 3, where we will be talking about energy storage. So energy storage can also provide this type of service, Black Start services. So coming to this frequency control ancillary services. So this frequency control also can be further divided into these three services. One is primary reserve ancillary services, secondary and tertiary. So these are divided based upon their duration. So primary reserve is it is required in a way for a very short duration. For us, for sudden changes in frequency, we need this. So we'll try to adjust this frequency to the nominal frequency using this primary reserve. And then when primary reserve is not working, then we'll go for the secondary reserve. Then tertiary reserve. We can see here the duration is increasing. So primary reserve is, it will act within 2 to 5 seconds. And this is based upon the governor action. Then the secondary reserve will react within 30 seconds, and it will, if a generator is providing that service, then it will have to ramp up to its capacity within 15 minutes, and then it will have to maintain it till 30 or half an hour. So these secondary and tertiary reserves have been added recently. Market from them for them have come up recently. You can, I have provided link. So this reference number 11 you can see. So these are the recent guidelines. Okay, AGC, I will discuss that. So these are the recent guidelines, the ancillary services regulations, which has been uploaded by CERC, and they have come up into, they have been adopted recently on December 5th, 2022. So now they have been enforced. Separate market and everything has been mentioned in that. So also, so battery is also going to participate in all these services. So we are moving towards including storage into our power system at all the levels, at our distribution level, even transmission, and as well as generation. So at generation level, we can see these black start services, transmission level and distribution level also. At transmission level, we can provide these type of services and can also help in relieving the congestion in transmission lines. We will further discuss about storage in the week 3. So these are the, if you want to go into detail of this ancillary services, you can go refer this regulation, these two, reference 10 and 11. So yes, Govind, you want to say something?
Yes, sir. Actually, I had one query. What will be the difference between the primary reserve and secondary reserve? What I understand is primary reserve basically is the outcome of RGMO, FGMO. So that is
What is
inherent.
the full form?
That's free governor mode of action. So
Okay.
one of the governor action wherein depending upon the sudden rise or drop in the frequency, the governor takes appropriate action. So
Correct.
wherein there is no involvement of the operator as such, because it's a system driven signal.
Correct.
So primary, so whatever the correction is there, will it be treated for the market treatment or what?
Market is will be for the secondary and tertiary reserves.
Okay, so primary, there will be no for deviations. There will be no compensation, right, sir?
Compensation it may be there, but there is no separate market for them.
Okay.
Because
There is no scheduling is not there for such kind
no,
of
yes, no,
deviations.
because it is very it is sudden, and it is
Right, right.
because of
For
the
seconds. Right.
inertia. Yes, it is because of the inertia of the generator. So because of
Right.
the inertia, the governor will take some action. So that is automatic. Even the
Sir,
secondary reserve is automatic, but they will
yes, AG
be
signal is auto generated.
correct. That is also auto generated. So both primary and secondary reserves are automatic, but because primary is very, it's difficult to have a market for this primary because it is very uncertain. It is very sudden. So taking any manual decision within such a short duration is not difficult. So we have already we have automated that part. But secondary and tertiary, we have market for them, and for them, some generators, there are certain criteria which are mentioned in the regulation. Which generator, what are the criteria for generator who can participate, who cannot
AGC.
participate for this one, for secondary as well as for tertiary. So this AG signal will also be automatic, but these generators will have to apply for that. Means they will have to participate in
It's
the
not
market, bid
mandatory.
for
Okay,
that.
okay. No mandatory. It's not mandatory. Okay.
Means right, so they have to bid for that.
Okay.
So for that market design, they have given the criteria for how the market will be there, but now we have to incorporate that into our market softwares also. So
Sir, just one more query, which is in continuation to the inertia which you mentioned. Over the period, what has happened is the thermal participation is going down.
correct.
Okay, so with the RE influx, how will we be able to manage this inertia? Because inertia helps a lot whenever there is a frequency dip.
That is true.
So, how are we going to tackle? Any thoughts in this regard?
Okay, it's a very good question. It's very apt to the present situation and even a very hot topic for research for the future direction which we want to achieve. Because we want to achieve a very net zero by 2070 and all these targets are there. That means that we'll have to again further reduce our thermal. So an inertia will further go down in that sense. But right now what is happening, we can thermal is still there. As we have seen, the installed capacity is around 50%. Still thermal is there, but that is installed capacity. But even the if we see the instantaneous generation, in that thermal is still having 70% contribution, even around 70 to 75% contribution. Recently there was somewhere in SRLDC report, so they have mentioned that the maximum instantaneous renewable generation is around 28%. Rest is thermal or hydro. There are even certain states like in this Southern Regional Load Dispatch Center, there are states like Andhra Pradesh, or I think, I'm not sure, either Karnataka or Andhra Pradesh. There have been some times where there was 100% renewable, but that included hydro also. So balancing part was done by the hydro, because hydro also we cannot neglect. When we are saying that thermal are going down, we are forgetting one fact, that hydro is also there which can provide inertia.
Okay.
So right now maintaining that inertia is not a problem, because thermal is still on a very higher side and we have hydro also. I will give you some example of countries which have already achieved this target of 100% renewable. Countries like Tasmania. Tasmania is not a country but a part of Australia, one island. So Tasmania has 100% renewable penetration. So that 100% includes around more than 70% is hydro, and the rest is solar and wind. So because of hydro, they are able to easily balance and also maintain the inertia. Similarly, Iceland is there, 100% renewable penetration is there. Maximum, because it is dominated by hydro as well as geothermal. Both are again having inertia. So they are also not having that problem. Similarly, Costa Rica, there are all these countries, these are mostly hydro dominated. So maintaining a balance in hydro dominated system is not that difficult. We have been doing that since several years, several decades. But the challenge is now will come when countries like India, where we don't have sufficient hydro potential. So we are only left with options like solar and wind. And if we are decreasing solar, then another option is that there are some techniques like virtual inertia. So virtual inertia concept, they are being embedded into the inverters of the solar and wind generation. They can also emulate like normal conventional generator to provide inertia. That is also being done. So this is a challenge, and we are working. We are continuously. We have to work in this direction. I
Okay,
hope.
sir. Okay, thank you.
Okay.
Thank you, sir. Thank you.
Okay. Thank you for this. Was a good question. Akansha, so AGC is automatic generation control. So it is embedded in each of generator, and actually it is a very big topic. It itself will take time. So I think you can refer any standard book on this power system dynamics and stability. There is one book, Prabha Kundur. that you can refer for AGC. So it's actually the main purpose of this is to maintain the frequency, and how much each generator should contribute in maintaining that frequency, that is decided by this AGC based upon some droop characteristics which is embedded in the control of these generators. Akansha, is that okay? Actually, it will take time. You mean kind of automation in generator? Yes. Yes, this is also automation. It is a part of control system which is there in generating systems. In their substation, that control is embedded, and it also communicate with the control center, which issues that control signal. So for that we need communication. There is a communication between them. So this primary is also automatic, secondary reserve, ancillary services is also automatic. For tertiary, this is not automatic, this is manual. We have to, generally the generating stations, they are intimidated by the control center, like the dispatch centers, the regional or state load dispatch center, they will intimidate the generator which has to provide that service. You mean maybe gravity energy storage be a solution for this spinning Mars problem? Gravity energy storage. I don't have much idea about gravity energy storage. Akansha, can you tell how does this work? Gravity energy storage? Actually, I have not read about this. Means I have come across.
It's
Yes.
Yeah, it's kind of like pulley. Just when we have an ample amount of energy, the pulley, or you can say any hard mass, will be pulled up in the up direction, and then whenever we want electricity, same phenomena is released. The pulley will be released, and the energy conversion happen, and like mechanical energy converted into electrical energy, kind of something.
Correct. Okay, this is similar to kind of flywheel.
Yeah, it's kind of like, or you can say like we have that hydro. In hydro, we have that spinning reservoir, like a reservoir for future energy storage purpose. Same phenomena is happening in this gravity energy storage.
Correct. Thank you for this explanation. That is true. Even energy storage can most of the energy, especially if you see around world the existing storage which are being used for these frequency regulation services.
Yeah, it's like hardly in 2 or 3 countries it's actually working. So still we need a lot of R&D in this, in gravity energy storage.
Because right now they are on small scale, I think.
Yeah, it's on a small scale.
But if we see about the large scale, then we have these flywheels and lithium ion storages which are being used for providing these frequency regulation services. So more about these energy storage we will also discuss in week 3. But energy storage are certainly a very good candidate for providing all these kind of services. Energy storage can provide all these services, and apart from these, several other services. That is why energy storage is gaining so much importance. It can actually help in each and every part of our system. So let us move to the next. So this we have discussed. Next question is this. So which standard belongs to the wide area situation awareness? What is the answer for this? Any guesses? Okay. So Nitesh, A is it's not correct in this for this one. Any other guesses? So correct answer for this question is D. IEEE C37 for wide area situation awareness. And so who can tell me that what do we need for this wide area situation awareness? Which is the essential component or equipment required for achieving this wide area situation awareness? We have come across this in week 1 material, and also we will discuss further about that equipment in the upcoming protection aspects, and the protection aspects will be discussed in the subsequent weeks. So that equipment is phasor measurement unit. So by using PMU, we are able to get the data from different substation, and then we do this state estimation. Different state estimation algorithms are run to get a picture, we can say, of the entire power system, and then take appropriate control actions if there are any problems. So this is the next question. I think this is the easy question. Do you provide some light on energy service interface? I think energy service, this is a part of your assignment also, so I will not be able to answer this question at this moment. But in the next week, if you still have doubt on this part, ESI, energy service interface, we can certainly discuss it. Is it fine? Yes. So since the questions which have been covered in your assignment, which is due on February 8th, that I am not covering here. But after the assignment is done, and still if you have doubts in those questions, we can take up those questions in the next week discussion. Yes, the answer is correct, Akansha. The voltage sag is not measured by a smart meter measurement. So who can tell me what is voltage sag? Anyone would like to answer this question? What is voltage sag? Voltage sag, voltage swell, flickers. You would have come up, yes, sudden dip in voltage. Yes, correct. We'll further discuss this in the next slide. You think you would have come across these terms like voltage rise, voltage sag swell, flickers, frequency deviation, harmonics. So all these are a part of a bigger term which is called power quality issues. All these terms fall under that category of power quality issues. So what are the other? So we can here one is power factor, RMS voltage, energy consumption. What are the other things which we can measure using smart meter? Are there other parameters that we can measure using smart meters? Current, correct, Sunil. Any other? Reactive power, correct. Correct. We can measure active power, we can measure energy consumption, we can measure reactive power, RMS voltage, RMS current, and then power factor. But voltage sag is not measured by smart meter. That we have to, because it is not instantaneous. It is not decided based on instantaneous RMS voltage. Let us see the definition. What is voltage sag? Let us see in the next slide. So here we can see. So here are these some of the power quality issues I have mentioned. So one is interruption, then voltage sag or swell, transients, noise, harmonic distortion, frequency variation, and flickers. Interruption is also a power quality issue. We may think that it might not be a power quality issue, because when interruption is there, only thing is that we don't have electricity at our home, but there was no problem with our devices. How can it be a power quality issue? It is a kind of, we can say, reliability issue. But there is a problem. There are some customers for them interruption is a power quality issue. Can you recognize or remember any of such a consumer for which interruption is a power quality issue? So for to give you a clue or an idea, that these are the consumers which require almost need 24-hour services. They need 24-hour power. And if they don't get that much, then they cannot operate. So they have to, hospitals, we can say in one sense, that is, suppose an operation is going on in operation theater and suddenly there is a power cut, then that is a power quality issue. More than the power quality issue, it is a matter of life and death for the patient. So we can say in hospitals, especially these OT and intensive care units, they are such consumers. And another very good example of this is these data centers. So they need 24-hour services, and for this reason, the hospital data centers, they have backup generators, diesel based or any other kind of generator, to have uninterrupted power supply. Even storage can provide that, but although right now it is not that economical, so we are using diesel generators. But in future, storage, if it becomes, yes, it will become economical, so then we can use storage as well. So here we can see this is the pure graph, which is pure sinusoid. In the bottom graph, we can see there is a sustained, a temporary, not permanent, temporary dip reduction, not dip also, reduction in the RMS, voltage RMS for few cycles. So there is a temporary RMS reduction in the voltage. There are specific standards for this also, for how much duration it should be there to be termed as a voltage sag, and what is the amplitude, what should be the amplitude. Usually it is below 0.9. If the per unit voltage goes below 0.9 per unit for few cycles, then it is termed as voltage sag. And if it goes beyond 1.1 per unit, it is called voltage swell. Okay, so any doubt in this part? Otherwise, we'll move to the next question. Okay. So this is the last question. In advanced metering infrastructure, each smart meter communicates with MDMS and DNS, correct? Anyone else would like to guess or would like to answer? So what is the full form of MDMS? Anyone would like to volunteer? Yes, that is correct, Kansha. Meter data management system. So we have smart meter at our homes, and we have a communication channel between the utility and our house. Through the communication channel, the data flows, the information goes to the utility data control center, and there we have this meter data management systems. So now questions are over, so I would like to now have your doubts. If you have some doubt in week 1 material, you can ask questions. And also I would like to have some suggestions. If you want to suggest how we should we should go about these live sessions, if you have any suggestions regarding that, that is also welcome. So these are the references, and you can go through them. So we'll upload these slides, will be available on the portal, and you can access them. Slide as well as the recording will be available. So if you have any doubts in the material which was covered today and also in the week 1, we can discuss. For week 2, we will meet next week then. So I will be here till 8 p.m. So you can ask questions. So are there no doubts? How a synchronous generator can be run at asynchronous speed? You can do that using controls. The type 4 wind, which is PMSG, permanent magnet synchronous generator, they do that operation. They allow that operation. For them, this manipulation is done by the converter. So before feeding it to the grid, the converter is there. That converter is able to do that. How that converter works, do you want to know that? For that, I will have to refer that details of the converter. Maybe next time, in next week, I will answer your question. Is it okay? Okay. So please, I will also remember, even if somehow if I forget, then please remind me. I will answer this question. So if there are no question, I will ask one question. We come across these terms very often. So I think you would have heard of these, even in lectures, you would have heard of circuit breaker, reclosures, isolators. Oh, what are these? What is the difference between an isolator and a circuit breaker and a recloser? Can anyone tell? The main purpose of this live session is to have to clear your doubts and also to have an interaction so that we can learn from each other. Do you have any suggestions to on how to improve this conduct of this live sessions? Do you want me to add something extra, or do you want me to change the pattern which I have followed today? Or do you want me to discuss these lectures in more detail? Anyone, can you answer? Was it a helpful session today? Okay, so thank you. Yes, Nitesh. Nitesh, you raised your hand. You want to say something? It's a very good and more informative. Thank you, Sunil. So, Nitesh, do you want to say something? You had raised your hand. Yes, that is helpful. Thank you. So, would you like me to change something in the way we went through today's live session? Any suggestion that would make it more useful for you? I was thinking that I will cover this in 1 hour, then we can have doubt session for 1 hour, but it went through. But so still we have time. You can ask doubts. Yeah. So my question is still open. What is the difference between circuit breaker, isolator, and reclosures? This will also come again in subsequent weeks when we will discuss about the protection aspect. Isolator, offload breaker, correct. Sunil is correct. Its isolator operates only when there is no load. So we cannot operate because there is no arc quenching mechanism in isolator. In circuit breakers, we use these, like SF6 is used, or some other materials are used, gases or something is used so that we can quench the arc which is generated when we open the contacts of the circuit breaker. So such kind of arc quenching mechanism is not there in isolators. So as Sunil has correctly pointed out, it is an offload. It works only on offload. And also we have these isolators. They also help us in, suppose we have only one feeder, then we don't need an isolator. But if we have one feeder, more than one feeders, and there is a fault in one feeder, and we want to remove that so that supply can be continued to the healthy feeder, then isolator is used. The circuit breaker at the substation will be opened, and the isolator will be then opened because now there is no current through the isolator. It will be opened, that feeder will be removed. Faulty section of the system will be removed, and the substation circuit breaker will be closed again, so that the supply can be resumed to the healthy section of the system. Okay, this is correct. Isolator is done. So what is the difference between reclosure and circuit breaker? So who would like to answer this difference between circuit breaker and reclosures? Reclosure is automatic. Even circuit breaker is automatic. There are differences between reclosure, and the reclosures have been introduced for specific purpose. In India, we do not use reclosures for our distribution system. We don't have these, but in US they use it. They do use reclosures and sectionalizers. They are used in concurrence. So sectionalizers are used in concurrence with these reclosures. Reclosures are the smaller CBs, circuit breakers, small size CBs, but they have some inherent mechanism in them. Suppose there is a fault because of a tree. Once a tree fell onto, because of wind, the tree just touched this distribution line. So the system will sense that there is a fault. But what happens, within few milliseconds, the tree again goes away. So if the system considers it as a fault, then the supply will be, then that portion will be cut off because the circuit breaker will open. But we don't want this, because just a tree came and just went away. This is not a fault. This is very, very, very intermittent, just for a very short duration. So we don't want such type of interruptions to be diagnosed or to be detected as fault. So to prevent this, we have these reclosures. They will count for these such type of occurrences. So they are timed with some delay between each occurrences and number of occurrences. Suppose there are 3 times the tree comes and goes, comes and goes. If this happens more than 3 times, then the system will think now it is a fault, and then the reclosure will open the circuit breaker. And the faulty section will be isolated by the sectionalizer, because sectionalizer and reclosers are tuned with each other. Sectionalizer knows how many such occurrences has happened. So when that number of occurrences increase beyond the specified, the sectionalizer will open that once the circuit breaker is open. So this is further increases the reliability. So we do not unnecessarily want to keep just isolating the system for some such small, not very small duration disturbances. So so please ask some questions if you have, because this session is meant for you, this is meant to be a doubt clearing session. So if you have any doubt, please ask. Any doubts? Okay, so time is over. If you don't have any doubt, then we can close the session. Then thank you all of you for joining and actively participating. So I will advise you to please come up with your doubts, because this is for your benefit, and take full advantage of this session. Okay, then thank you for joining. Let's meet next week. Thank you.